Welcome back to The Explainer. Today we're jumping right into a massive shift in how the modern digital world actually operates behind the scenes. We're going to explore the journey from the dark ages of exhausting manual server management to the absolute superpower of summoning massive global cloud infrastructure with literally just a few lines of text. So let's kick things off with a question. Imagine you're responsible for an application that suddenly goes viral. You now need to manage not one, not 10, but 10,000 servers just to keep it running. How do you update them, or fix them, or secure them without completely losing your mind? I mean, imagine the sheer nightmare of trying to log into thousands of individual computers by hand. It's totally impossible, right?
Well, here is our roadmap for this explainer. 1. The infrastructure headache. 2. The cloud confusion. 3. Infrastructure as code. 4. Meet HashiCorp Terraform. And 5. Real-world power. Modules.
Section 1. The infrastructure headache. Okay, looking back at the traditional era, deploying an app meant you literally had to own the physical building where your computers lived. We started with these massive on-premise data centers, right? And then we made a huge leap to renting from cloud providers. But to reach true modern efficiency, the industry really had to evolve one step further into infrastructure as code. Because in that traditional era, the pain was just real. Think about this exhausting loop. A user experiences a crash, they raise a support ticket, and then that ticket goes to a sysadmin who literally has to walk into a freezing cold data center, physically find the failing server out of hundreds on a rack, and manually type commands to fix it. This kind of manual configuration meant extreme bottlenecks, sky-high hardware maintenance costs, and an agonizingly slow process to scale your app up when demand spiked, or scale it down when it dropped.
Section 2. The cloud confusion.
To escape that physical data center, the tech world shifted to renting resources from massive providers. But how does this actually function under the hood? Well, the cloud is essentially just API-driven renting. When you want a new server, an API call is made, and a virtual machine is instantly lent to you. And instead of writing raw code, most people just log into a cloud UI dashboard, click a few shiny buttons, and boom, the server is running. The UI nicely abstracts all those complexities away.
But, here is where the cloud confusion begins. If you're manually clicking through cloud UIs to create and update resources across multiple regions, humans make mistakes. Let's say you have an app in 2 regions. You log in, you click through the menus to update your database in region A to MySQL version 8.3, which has all the latest security patches. Great. But it's Friday afternoon, you're exhausted, and you just forget to manually repeat those 50 clicks for region B. Now region B is stuck on MySQL 8.1 and is wide open to attacks. This leads to a massive, dangerous mess known in the industry as configuration drift.
Section 3. Infrastructure as code.
So infrastructure as code, or IAC, is exactly what it sounds like. It's the practice of managing your infrastructure with written configuration files rather than manually clicking around a graphical interface. By writing your infrastructure as text, you can actually store it in version control systems like Git. And that's a game changer, because it means every single change is tracked, reviewed, and perfectly reproducible. Need to spin up a new region? You don't click 50 times, you just point your code at a new region and run it. Perfect consistency across thousands of servers.
This really brings us to the core philosophy behind modern IAC, which is a declarative approach. Think of it like a desired state metaphor. If you want a house built, you don't write down an imperative list telling the builder exactly how to lay every single brick and pour every ounce of cement. Instead, you declare your desired state. It's like handing a magic genie the completed blueprint and saying, make my infrastructure look exactly like this. The IAC tool figures out all the exact steps required to make reality match your blueprint.
Section 4. Meet HashiCorp Terraform. Now sure, there are other tools out there, but Terraform dominates the space for one very specific reason. Tools like AWS CloudFormation or Azure Blueprints are fantastic, but they lock you into their specific cloud. Terraform's absolute superpower is that it's cloud agnostic. By using middle layers called providers, developers can use the exact same workflow to deploy resources to AWS, Google Cloud, Azure, or even local on-premise servers. And working with Terraform really just comes down to this incredibly elegant, highly secure 3-step workflow. First, you write your desired state in your config files. Second, you run a command called plan. Now, this is absolutely crucial. Terraform compares your code to what actually exists in the cloud right now, and it shows you a highly detailed preview of exactly what it's about to add, change, or destroy. It's basically Terraform safely asking, are you sure before you spend any money or accidentally delete a database? Finally, if that plan looks good, you hit step 3, apply, and Terraform automatically provisions the whole shebang to the cloud.
Section 5. Real-world power, modules.
To operate at an industrial scale, we use modules, which are basically prepackaged, reusable blocks of Terraform code. And just to prove their sheer dominance in the industry, over 181.9 million, that is the all-time download count for just one single module, the official Terraform AWS VPC module. A VPC is a virtual private cloud, the foundational network your servers actually live inside. Setting that up manually is notoriously tricky, but Terraform modules change the game entirely.
So the crucial takeaway here is what this module is actually doing for you under the hood. By writing just a few simple variables in your code, this single module automatically configures a staggering amount of complexity. It handles routing for private subnets with internet access and highly isolated intra-subnets with absolutely no internet access. It can intelligently spread your NAT gateways across different availability zones to save you costs. It integrates with complex transit gateways, and it automatically pushes your VPC flow logs securely over to CloudWatch. Trying to configure all of this via a cloud UI would literally require hundreds of error-prone manual clicks. With the module, it's virtually instant and perfectly accurate every time. I think this quote perfectly summarizes the ultimate victory of infrastructure as code. Reusing configuration files ensures consistency across all your different environments. Because of these powerful open-source modules, the playing field has been completely leveled. A junior developer working on a weekend side project can now deploy the exact same highly secure, perfectly architected AWS network configuration as a massive billion-dollar tech giant simply by pulling down the Terraform module and typing Terraform apply. So we've journeyed all the way from freezing physical data centers to manually clicking around in cloud dashboards, right up to the magic of declarative code and the massive scale of Terraform modules. The headache is finally gone. The blueprint is in your hands. You now understand the incredible power of infrastructure as code. The only question left is, you have the code. What will you build next? Thanks for joining me on this explainer, and I'll catch you in the next one.